Welcome to section 6.6. In this video, we are going to learn about a couple special cases that happens occasionally when we solve linear equations. So in certain situations, you can get something that we refer to as all real solutions or no solutions. So what happens is these are two different cases where we get all real solutions or no solutions. So before, when we've been solving linear equations, for example, when we get something like, when we solve an equation, we get something like x equals 7. That means this right here, this is a solution to the equation. So let me actually write out an actual equation here. So let's say we have x plus 3 equals 4. So when we solve this, we subtract 3 on both sides. We get x equals 1. So x equals 1, this 1 here is a solution to this equation, right? Because if I introduced this idea in the beginning of this unit, where once we solve for x and we plug that value back in for x and we get a true statement, that means that this is a solution. So if we plug in 1 for x, I'm going to write check up here. So if we plug in 1 for x, we're going to get 1 plus 3 equals 4. If we add 1 and 3, we get 4. And 4 does indeed equal 4. So we know based off that, once we checked our solution, we got a true statement that 4 equals 4. We know for sure that this is a solution. But what happens occasionally is we will get a true statement, but in a different way, where we get, and we'll see that actually coming forward. So when we get a true statement like 5 equals 5, when we're in the middle of solving an equation, that is indicating that there are multiple solutions, which means there's more than one, which is known as all real solutions. Now, if we solve a linear equation and we get a false statement, something like 3 equals 5, that is indicating that there are no solutions to that equation. So let's just begin and work through this. So we have to determine if the following equations have either no solutions or all real solutions. So to do that, we're just going to simply solve for x. And when we solve for x, we are either going to get something like a true statement, or we're either going to get a false statement. So let's see what we get when we solve for x in this first example. So I encourage you to pause the video and try this one on your own. Now let's work through it together. So recall, to solve for x, when we have x's on both sides, we're going to subtract x to get x on both sides. And what we may notice is that these two x's cancel, but this x and this x also cancel. So we're just left with 3 equals, and then this x minus x cancels. So on this side of the equation, we get 0. So is this a true statement? Does 3 equal 0? And 3 does not equal 0. So here, let me write this. 3 does not equal 0. So in math, a lot of times, you will see an equal sign with a dash through it, and this means not equal to. So I'm going to write this up here. This means not equal to. So 3 is not equal to 0. So therefore, if we look at the cases that we have here, if we don't get a true statement, that means we have no solutions. So this one, we get no solutions. Looking at example 2, our first step would be, because we just have x equals x, so we're just going to subtract x on both sides. So these x's cancel, these x's cancel, so we just get 0 equals 0. Now, is 0 equals 0 a true statement? It is. So therefore, because 0 equals 0 is a true statement, for this equation we get all real solutions. Looking at example 3, we have 7 plus x equals x plus 1. So I encourage you to pause the video and give it a go. And now let's work through it together. So our first step here, because we have an x on both sides of the equation, is to subtract x. And then our x terms cancel, so we're just left with 7 equals 1. And 7 does not equal 1, so we have no solutions. Now looking at example 2, we're going to combine this 2x and 3x, and then combine the 7x and negative 2x. So 2x plus 3x equals 5x. And then 7 minus 2 is 5, so we get 5x. And then we're going to subtract. I'm just going to subtract this 5x from the left to the right because we can do that. You can either subtract this 5x from the right to the left, or you can subtract the 5x from the left to the right. It doesn't matter. So these cancel. We get 0 equals 0. And that is true. So this linear equation has all real solutions. Looking at example 5, I encourage you to pause the video on your own and try this one. And now let's work through it. So we have x plus 4 minus x equals 0. So you actually don't even have to really do anything in this case, because if you notice, we have x minus x. So these two x's, they just cancel. So we're just left with 4 equals 0. 4 and 4 is not equal to 0. So this equation has no real solutions. And then for this next example, we have example 6. All right, we have x plus x equals 2x. So we are going to combine this x and this x, so x plus x equals 2x. And we can set that equal to 2x. And then subtract by 2x. These cancel, so we get 0 equals 0. Therefore, we have all real solutions. Now, one thing I did forget, one thing I have not mentioned yet, is what exactly does all real solutions and no real solutions actually mean? So what this is telling us, so let's first look at all real solutions because this is the problem we just did. So what this is saying, all real solutions, what that means is you can plug in any number for x and you will always get a true statement, like 0, like it was 0. So let's just say x, let's just practice that. So let's just say if we wanted to plug in the solution x equals 3 to the equation. So we're going to plug in 3, so we get 3 plus 3 equals 2 times 3. So 3 plus 3 is 6, and 2 times 3 is 6. So the solution satisfies the equation. Now, if we try, let's try another random solution. Let's do x equals negative 10, just because we want to. So we're going to do negative 10 minus negative 10 equals 2 times, running out of room, times 2 times negative 10. So negative 10 minus negative 10 equals negative 20, and 2 times negative 10 equals negative 20. So this is also true. So you can see that you can plug in any number that you can think of into this equation, and you will always get out a true statement no matter what. But when you look at these kind of equations, regardless of the number that you plug in, you will never, ever get a true statement like we do here. So no real solutions means you can plug in any number you want, but you're not going to get a true statement. But all real solution means the opposite, the complete opposite. That means you can plug in whatever the heck you want as a number, and you will get a true statement every single time. So that's what that means. Anyways, so looking at example 7, we have 4 plus x minus 3 equals x. So let's start off by subtracting x on both sides. Actually, wait, I just broke a rule that we talked about. We don't want to do that first. And you might be like, why? Well, remember when we talked about, when we were in the video, when we learned how to combine like terms? This 4 and this -3 is on one side of the equation, right? And they are like terms. So we always want to combine like terms that are on one side of the equation first before we do anything else. So 4 minus 3 is 1. So we get x plus 1 equals x. So then we're going to subtract x on both sides. These x's cancel, and we are left with 1 equals 0. And 1 is not equal to 0, so no real solutions. Now, let's do example 8. So this one might actually just jump out at you automatically because I've done so many examples already. But we're going to subtract by 4x on both sides. So these x's cancel, and we're left with 3 equals, and this side becomes 0, and 3 does not equal 0. So therefore, this equation also has no real solutions.